Hello guys, so in this video I will talk about Bernoulli's equation. So this is valid for fluid motion which is not turbulent and is steady, and at each point the velocity remains the same and it is well streamlined motion. So let's say we have a tube of different cross section, but the fluid is moving through it, and it is a very streamlined motion. So let's take this cross sectional area here and here, and let's say the fluid in some time dt, this fluid has moved to this point and this fluid has moved to this point, and say the cross sectional area is A1 here, we have A2 here. Let's say pressure is P1 here and pressure from outside to this portion is P2. Let's say the height of this one is H1 from the base and this one is H2 from the ground. So we will use the work energy theorem, which basically says the external work done is equal to change in kinetic energy of the system. So our system is from this position to this position, which has moved from here to here. So basically this portion has moved to here. Okay, yeah. So the work done by external forces are two. First work done is by pressures, by pressure 1, by pressure 2, and the work done by the gravity. So work done by pressure 1, it will be, since it is from this direction, the fluid on the left hand side will push this fluid on the right hand side, and the motion is also on right hand side. So the work done will be P1 A1, this is force, and let's say it has moved by distance dx. Okay, now work done by the pressure P2 will be like P2 A2 and let's say dx, and now work done by the gravity is two-sided. Basically this mass has displaced, this has moved by height h2 minus h1. Basically this is the net movement, but the gravity is in downward direction, motion is in upward direction, so work done will be negative. So basically work done is given by force, which is mg, delta m of this times g and times the distance it has moved. So this is force times the distance, that is work done, and this is negative because the force is in negative direction. Yeah, this work done will be also negative because the pressure is in this direction and movement is in this direction. So now we have P1 minus P2 let's say this is dx1 and this is dx2, and we have P1 minus P2 and then we have A1 x1, then we have delta m g h2 minus h1. I will tell why we have done A1 x1 is equal to A2 x2, because that is an equation of continuity. Also, since the mass is it can't be destroyed. If it has moved from here a1 and the displacement is x1, then we have a2 cross section here, then it has to displace by x2, so that the volume of this displacement is same because it is incompressible. So this is, you can say a1 x1 or a1 dx1, you can say basically dx1. Now we have p1 minus p2, a1 dx1 minus delta m is given by rho a1 dx1 h2 minus h1 times g. This is work done, and now we have change in kinetic energy. So this part remains the same, and so all the particles here will have the same kinetic energy, so there is no change, but the change in kinetic energy is happening here, and this portion, this has moved from here. So let's say the velocity here is v2, velocity here is v1. Again, half mass will remain same, half m v2 minus v1 square. This will be half rho a1 dx1, this is mass, density times volume, and this is not like this, this is v2 square minus v1 square. Now if we equate them, that is delta work done external is equal to change in kinetic energy. This portion is p2 minus p1, p2 minus p1, a1 dx1 and rho a1 dx1 h2 minus h1 times g, and change in kinetic energy is half rho a1 dx1 and v2 square minus v1 square. Now a1 dx1 portion is cancels out from everywhere. We have p1 plus half rho 1 sorry, this is p1 minus p2, p1 plus half rho 1 half rho v1 square plus half plus rho g h1 from here, and this is p2 plus half rho v2 square plus rho g h2. So if we have pressure p1 here and v1 velocity, and we have p2 pressure here and v2 velocity, and we have h1 and h2, we can use this equation. So if we know these any 5 values, we can calculate the 6th value, and rho remains the same, g remains the same. It is the density of the fluid. So that means p plus half rho v square plus rho g h is equal to constant. That is basically the Bernoulli's equation. So thanks for watching this video. If you have any questions, you can put below and I will try to solve those problems for you. You can just put the number of problem number, or if you want to solve get it solved, or you want to understand any concept in physics, you can basically just comment it down, and you can like, share and subscribe. Thank you.